So while we're moving workshops and we're unboxing things and putting things away, and I've got a clear workspace, I just thought I'd give you a little bit of an overview on some laser tubes. So we've got some glass DC tubes at the front, little 40 watt. These range in lengths and wattages. At the back there you've got a 220 folded tube. These are HT water cooled. I've seen some people try to air cool them, but they're designed to be water cooled. There's three main things with these tubes is temperature. Don't really run them above 25 degrees. General rule of thumb is about 20 degrees. You don't want to run them too cold, otherwise condensation can be a bit of a problem. And you definitely don't want to freeze them, otherwise they shatter. This customer was using antifreeze, but he got the wrong mix. High voltage, so you want to make sure that everything's pretty well insulated on your high voltage connection. These nowadays they come pre-tailed, but if not, make sure that your HT is well insulated. Resin filled heat shrink, rubber tubing, 100% silicone rubber sealant. The other thing on these is don't overrun them. 90% of the machines coming out of China, they're not balanced to the power supplies. They tend to be trying to run them at peak power. It used to be a rule of thumb which was 24 milliamps, 40 watt, 26, 60, 28, 80 watts, but it's all changed over the years. They have fixed the milliamps down. Just go with your recommended manufacturer's recommendations on those things. But again, that general rule of thumb, don't overdo it, otherwise you will reduce the life of your tube. There you go, glass DC tubes. This one's of an age, you can see it's starting to go white. It's still got plenty of life left in it. It's 4 years old, but once it starts to lose the power, once it starts to break down, if you try and squeeze the last bit of life out of your tubes, unfortunately it can put strain on your power supply. So when you notice it's going, you notice it's starting to go white, you're losing power, change your tube. We've got some metal RF laser tubes, radio frequency to stimulate the gases inside to produce your laser. These all tend to be air cooled, but you know, they do water cool these things. You see the little fans on the top. They used to be quite noisy, but nowadays they're putting silent running fans on them. They're also linking them into the temperature control, so they only kick in when they get to a certain temperature. You've got more control over the RF tubes than you have on the DC. The DCs tend to be more towards a continuous wave. They are pulsed, but it's so rapid that it tends to be down that path. They're leaning more towards being a continuous wave than they are a pulsed laser. Whereas this is where the RF has got the advantage on it. You can turn the pulses right down, and you've got a little bit more control over them. Whereas the DC, you have got a striking power. They don't tend to run anywhere below 10%, give or take. Longevity, I mean, they have started to ceramic line these things now on the RF side of things. They're sort of saying, no, we're ceramic line tubes now. There's a reason for that, and I think the reason is they were getting bleed out of the aluminium, which was shortening the lives. So I don't know whether it's an advancement or it's to cure a problem, but anyway, they do tend to ceramic line these things now. It seems to be well advertised that that's the path they've gone down. Main difference, you've just got a little bit more control over the RF than you do on the DC. DC is a little bit more stable than RF, but you've just got that control over it, so they do give you that edge, especially on engraving and cutting papers, fabrics. You know, you've just got that control where you can set the pulses of the laser rather than it being a continuous wave where you're having to use the speed to get the pulses down. Then we've got next jump, well, we're jumping decimal places on the old wavelength scale, whereas those are like 10,600-ish wavelength. You're coming down to 1,060-ish wavelength. So this is a diode laser, so that's basically a diode in there. Fibre optic cable runs it up to an optical cavity. you've got some gain media in there that is passing through, and then it's hitting a Q switch, which is there to pump the laser. It's diode, direct diode. This was superseded quite quickly by fibre lasers. YAG, yttrium aluminium garnet. We've got one missing out of this collection, which is the crystal, which is basically you had a chamber, you had a crystal, and you had heat bulbs basically to pump the crystal, and then you'd have an optical cavity, a train to pump it up using a Q switch to pump up the power. Inefficient. They have swapped them now. They do use a lot more diodes now. It's still there. It's still about is crystal lasers, but then it was superseded by diode, which has then been superseded by fibre lasers. Instead of a doped crystal, they're doping the fibre optics. So basically, this is a fibre laser. See inside all the fibre optics, the doped fibres, and in there again you'll have a diodes. There we go, you just see them, and you see them attached up to the fibre optics. Again, different to the CO2s as in the wavelength. So basically these are pretty good for plastics, woods, organic things, and when you jump in decimal points on the wavelength, these are really good for metal marking, some plastics, but yeah, mainly metal.